Hello everyone! In this video, we will begin building our website. In this initial phase of the final project, we will create an index and index over 3000 documents. We will use the size and from parameters to control the number of results returned in queries. We will also perform multi-match queries to search across multiple fields. And the theme of our final project will be about astronomy. Here is a video that demonstrates what we are going to build. You can see that here we have an input text where we can type in the query, and here we'll get the documents. And these documents are related to what we type. We are going to build both the frontend and backend. And as you can see, here by default we get just 10 documents, but in later videos we will improve the search functionality to modify these values. I hope that you liked how the website looks like, and in the next slides we will see how to build this. Now we will focus on the front end. As I told you in the beginning, we will be using Vue.js to create the front end, and it is done for you because we want to focus on using Elasticsearch in the backend. So you just need to install some dependencies. As I told you, you can find the front end or the final project on my GitHub repository. Just click on the image, or you can find the link in the video description. I'll click on the image. So now we are in GitHub. This is my repository, and you will need to clone it to access the final project and the dataset we will be working with. Once you have cloned or downloaded the repository, go ahead and open it in your favorite code editor. I am using VS Code, and as you can see, on the left, we have the notebooks folder, the data folder, and the final project folder. Open the final project folder. Here you have two subfolders, the final code. Here you'll find the final solution and the getting started, where you have just the front end and we will build the backend together. Open it. And here you have the front end. You can see that here we have a lot of files. Now, what you need to do is open your terminal and let's try to navigate to the front end folder. To do that, you just use the cd command. Here, I'll go inside the final project, getting started, and finally front end. Here we need to install the front end dependencies. Make sure that you have Node.js installed on your machine, then run npm install. This will create a new folder called Node Modules that contains all the dependencies. Once that's done, you can start the front-end server by running npm run serve. Click on this link and boom, your website is live. It looks great, but if you try searching for something, let me search for the Andromeda. Here I am pressing the enter key, but nothing happens, and even if I click on this icon, I get nothing. That's because we haven't set up the backend. Don't worry, that's what we are about to do. We have finished working on the front end. Now we will move to the backend. We will be using Python, FastAPI, and Elasticsearch. In this part, we will install the dependencies for Python, set up the backend server so that we can make requests from the front end, and configure Elasticsearch to be able to make queries. Now I'm back to VS Code. Here I will collapse all folders, and if you look, you'll find a requirements.txt file, and here are the requirements or the dependencies for Python. One more time, open the terminal. If you don't already have a Python environment, make sure to create one. I'm using Anaconda and I already have my environment set up. Activate your environment, then run this command. pip install -r requirements.txt. If I run it, nothing will happen because I already installed the dependencies, but for you, you will see that the packages are going to start to install. Once that's done, close the terminal and navigate to the backend folder. Open final project, open getting started, and here is the backend folder. Let's do the same in the terminal. cd final project, getting started, backend. Now if I close this file and open main.py, you can see that we have nothing. But here we will set up the backend server. But before that, I'll create a new file called indexdata.py. This one will be responsible for indexing the data. If I open data, the data folder, I have added another JSON file. This one is called apod because basically these are entries that I scraped from the NASA's apod website. This is how the website looks like, and as I told you, the theme of this final project is astronomy. So if I start clicking on the hyperlinks, you can see that we get some images about the universe. Let's look for another one, for example this one. And what I did is that I wrote a script that will go through all those entries, take the title, take the description, and the date, the published date. And I created this data for you. And I'm also using this data on my own website. Basically, it's a remake of a pod website. It looks very old, as you can see, but I try to take the same data and make the website beautiful. So if you are someone who enjoys astronomy, please visit my website and give me some feedback if you want me to add something. And this is where I got the idea to work on the search experience, because currently on this website, I am just using regular expressions to find documents or to find the related images to your query. But when I learned about Elasticsearch, I thought this is a good idea to implement this on the website. So index data is a script that will read apod.json and index all those documents inside it in Elasticsearch. We will start by defining a function called indexData that takes a list of documents as input. And here I am using type annotation to indicate the type of data that we are working with. Inside the method, we will create an Elasticsearch client using a helper method called getEsClient. This one we will put it in a utility file. So let's do that. utils.py, because we will be using it in multiple scripts. You should be familiar with this. We have been doing this a lot in the notebooks that we created. You can see that here we are creating an instance of the Elasticsearch class. And here, because we are using Docker, we are connecting to a local host. And if the connection is successful, I'm going to print the cluster info. But if for some reason you forgot to start the Docker container, you'll not be able to connect, and we are going to show this message. The problem with this method is that if you run the script and you forgot to start your server, this will run once and stop because we will not be able to connect to the server. So let's add retry mechanism to try and connect multiple times, and between each connection attempt we will add a time.sleep so that we wait a little bit before trying to connect again. So this is how you do that. Here I have two parameters, max retries and sleep time. Here I have a while loop, so I will be executing this block 5 times at most. So let's pretend that we started the server and that takes 10 seconds. And then I immediately started this script. So the first attempt of connecting will not succeed because the container did not start. So here we'll try to wait for 5 seconds before making another attempt to connect to the server. And this will give us some time to make sure that we will connect, even if the container takes a little bit more time to start. And if after making all those attempts we don't succeed, we are going to raise a connection error. Now let's close this file and go back to index.data or indexdata.py, and here we need to import this method. Next, we need to create an index in Elasticsearch. We are going to create a method for that. Let's call it createIndex, and here we have some things that we need to import. First, let's import Elasticsearch, and here we have a constant. Because I want the name to be reusable, I might use it in multiple scripts. I will define it as a constant in a new file called config.py. And inside, I'll just take this, put it inside, and let's name it apod. Now close config.py and import the constant. As you can see, the create index is very simple. It just deletes the index if it already exists and creates it another time. And here we get the response. Now let's call that method from within index data because it is the main function. And the logical next step is to read the data and index it in this newly created index. For that, I will create again another method that will do this. And here I need to import tqdm. So from tqdm, import tqdm. And here we are using the bulk API. You can see that we are reusing the things that we have seen in the previous episodes. So I think you should be familiar with all these terms. So here we are getting the list of documents, we are getting the ES client, and here basically we are making the operations and passing that to the bulk API. After executing this method, all those documents are going to be indexed. Let's not forget to call that method from within index data. Finally, if everything goes well, I will show this message. Here I'll just print how many documents were indexed, and here let's import bprint. And now we need a way to execute this script from the terminal. That's easy to do. Just add this block, and here I need to import JSON so that I can read the JSON file. Inside this block, we get the list of documents and we pass that to the index data method. This JSON file contains, I think, over 3,000 documents. Yeah, it contains 3,255 documents, which is a lot. That's great. And all of them come from NASA's website. So now I think we are done with index data. Now we need to go back to main.js or main.py so that we create the server. But before I do that, I need to index the data. Again, open your terminal and start the container. Open the terminal, and here I'm on the final project, so that's not the right path. So let's go to final project, getting started, and backend. Now all I need to do is run Python index data. Here it is telling me that it couldn't find the file. That's because this relative import is not correct. So let's fix this. I need to go back 3 times before I find the data folder. Now I just want to show you the retry mechanism. So I'll just stop or restart the container. Now let's again run the same script. You can see that here it says could not connect to Elasticsearch, retrying, and after that it freezes for 5 seconds. It tries to retry again, and eventually we will succeed. Here we get another error inside create index. Yeah, so here I was passing the index name, but I already imported it, so I don't need to do that. I think, yeah, inside insert documents also, I need to remove this. I think we are fine. So let's save the file and retry again. Okay, so now everything went well. You can see that we printed the clusters info, and after that we indexed the data using the bulk API, and here we printed that we indexed 3,000 documents into this index. Now let's create the API using fast API. Add this code to main.py. Here we are creating a fast API app, and we are adding middleware to allow the front end to make requests to the backend, because by default the front end runs on a server and the backend runs on another server. And by default, if you are trying to make requests from a server to another server, you'll get blocked by coarse middleware. So this is why we are adding allow origins, and here by adding this asterisk, we mean that any server can talk to any server. So we will not block requests just by adding middleware. After that, we need to define the endpoint. An endpoint is the URL that the front end will use to send the request. So if I want to search, let's say that I am typing in the input text and I want to take whatever I typed and send it to the backend. I will try to go to this URL and send the query to the backend, and the backend will receive it because here we are defining this get endpoint, and this endpoint is linked to this search method. So whenever the front end sends something, the search method will be called. And here we have some parameters like search query, skip, and limit. Skip basically is the offset. It's the from parameter in Elasticsearch, and limit basically is the size. Inside the search method, we will do a simple search query, like what we used to do before. Again, we create the ElasticSearch client. Here we are using the same method that we created before. We call the search method. We provide the apod index, and inside body, we are making a multi-match query. This type of queries allows us to search in multiple fields. Let's say that I typed Mars. By using multi-match query, I will search if that term exists in the title and or the explanation. As I told you, we are using pagination. So skip is basically from and limit is size. And we are also using filter path to filter the results to get just the document which is stored in source and the score related to that document. And finally, we return the hits dictionary. You can see that in one method, we have used a lot of concepts that we have covered in the previous videos, like pagination, multi-match queries, the search method, pagination, and filtering the results. Now make sure to save all the Python files that you have created. Open the terminal and start the backend server. To start the server, you just run this command fastapi dev main.py, and you should see something that looks like this. Don't forget that my Elasticsearch container is still running, so make sure to run it if it is not. And I also need to run the front end. So let's go to Final Project, Getting Started, Front End. And to run the front end server, you run this command npm run serve. Now we can click on this link. Okay, we get the same result as before. Let me just close these tabs. But before you saw that we were not able to make requests because the backend was not set up. But now we have everything, so we can test this. Let's search for Mars. You can see that we are getting the images back, which is great. And you can see that here, sometimes Mars or the term will exist in the title. Sometimes you can find it in the explanation. And here you can click on the image if you want to see it in full size. Let's search for Jupiter, another planet. You can see that we are getting Jupiter images, which is great. I love this one. Look at Jupiter close to the moon with Jupiter moons. So here we have 4 Jupiter moons. That's awesome. Great, so this is actually working. And that's it for this video. In the next episode, we will improve the search experience with advanced Elasticsearch features. Until then, have a wonderful day.